Hi. At last lecture, we have seen the analytical curve by using parametric method. At first lecture, I told you there are two approaches are there to draw the geometry. First is the parametric approach. Second is the non-parametric method. The non-parametric method is different. In parametric method, you have to use one parameter to calculate the points on the curve. So we are discussing this point only, the parametric method to draw the geometry. And we have seen the different geometries. There are two types of geometries are there, and we are discussing only based on the parametric method only. Non-parametric method we are not discussing. And parametric method may two types of geometries are there: analytical curves, or known as also known as the conic section, because it is the intersection of the cone and the plane. And we have drawn these geometries: line, circle, ellipse. The parabola, hyperbola is not so important. So we'll proceeding with the synthetic curve. It is very important as far as the exam is concerned. So always one question will be there on synthetic curve. Synthetic curve, we have three types of curve: the cubic spline curve, Bezier curve, and B-spline curve. Today we'll see how to draw the cubic spline curve. That means how to calculate the pixels on this curve, on cubic spline curve. Cubic spline curve is also known as the Hermite curve. The another name of the cubic spline curve is the Hermite curve. So now today we'll see what is Hermite curve and how to calculate the pixels or the points on the Hermite curve. Okay, we are proceeding with the Hermite curve. Suppose I want to draw the Hermite curve. First I will draw the axis of the computer. It is the x-axis and y-axis of the computer. So this is your x-axis and it is the y-axis of the computer, and it is the 0, comma 0, the pixel 0, 0 of the computer, and you draw one curve. And to draw the curve, the information up to extreme point is not just enough. If suppose you have to line and draw the line, the information up to extreme point is enough to draw the line. But to draw the curve, the information up to extreme point is not just enough. So P0 is the start point and P1 is the end point on the curve. By using these 2 points, we can't draw the curve. We can draw the line by using these 2 points, but we can't draw the curve. To draw the curve, we need some extra information. So the extra informations are the curve caper tangent. So first I will draw the curve. Suppose the curve is like this. This is a type of curve. So to draw this curve, we should have to have the information of the tangent. It's called P0 dash. P0 dash is the tangent on curve at a start point. And then here one more tangent line is there, is P1 dash. So to draw the information, you should have to have the information of the four things. First is information of start point of the curve. Second, information of end point of the curve. Third, information of tangent on curve at start point. And fourth is information of tangent on curve at end point. By using these four information, these four boundary condition, we can construct the Hermite curve. Okay. So here I'm writing the four things we required to draw the Hermite curve, which is P0 having component x0, comma y0. It is the start point on the curve का start point है, and P1 it has component x1, y1 is the end point of the curve. So these are the start point and end point of the curve, and P0 dash is the tangent on curve. This is a tangent on curve at start point, and P1 dash is the tangent on curve at end point. end point पे we have drawn one tangent, and start point पे we have drawn the one tangent line. And by using these four information, we can construct the curve. The name of this curve is Hermite curve, and also known as the cubic spline curve. This is the Hermite curve, and also known as cubic spline curve. Why is called cubic spline curve? Because the order of the equation of the curve is 3. So here also we have to use one parameter which is varying from 0 to 1. So here the parameter key value, suppose I am using parameter u. U is 0, and here u will be 1. U is a parameter which is varying from 0 to 1, and you're supposed to calculate point in between the start point and end point of the curve. So here the parameter u is varying from 0 to 1. Now you have to construct the equation, and you have to write the cubic equation to calculate the points on the curve. Okay, so I'm writing the equation, and you have to use four different boundary conditions to calculate the coefficients of the equation. So suppose the cubic equation will be uh, here I'm writing the cubic equation for the curve P. P is the equation to calculate the points on the curve with parameter u. Summation I is equal to 0 to 3 because it's the cubic spline curve, Ci and u raised to I. So this is the equation. In that equation, u is a parameter which is varying from 0 to 1. By varying the parameter u 0 to 1, we can calculate the points. The P is the points ka equation. This is the equation to calculate the points on the curve by varying the parameter u from 0 to 1. I am writing this in submission ka equation. I am writing this same equation. If suppose P of u, you can write like this. First, I is equal to 0. So C of C0 u raised to 0 plus then I will be equal to 1. C1 u raised to 1 plus C2 u raised to 2 plus C3 u cube. So here submission ka sign I have taken 0 to 3. So up to 3 you have to write. So here we can write uh, C0 u0 will be 1 plus C1 u raised to 1 will be u plus C2 u square plus C3 u cube. So this is the equation to calculate the points on the ellipse. Suppose the equation number 1. By using this equation, we can calculate the points on the curve. So the C1, C2, C3, C4, C0, C1, C2, and C3, these are the four coefficients. And U is a parameter, and the C1, C0, C1, C2, C3 are the constant or coefficient. So the constant you have to calculate by putting the boundary condition. We have the four different boundary conditions, and by using the four boundary condition we have to calculate these four coefficients. So four boundary conditions are the start point information and tangent on start point, end point information and tangent on the end point. These four boundary condition we have. So first I will differentiate this equation with respect to u, so that I will get p dash ka equation. P dash of u, if you differentiate the coefficient constant number will be 0 plus c1 u, तो C1 is constant, U का differentiation 1 हो जाएगा, plus C2 U square का differentiation हो जाएगा 2U, plus C3 U cube का differentiation हो जाएगा 3U square. So this is a differential equation or tangent equation. C1 plus 2 C2U plus 3C3U square. It is the equation number 2. The first equation is the equation for the points on the curve. Second equation is the tangent on curve. By using first equation, we can calculate the points on the curve, and by using second equation, we can draw the tangent at any point on the curve. In between, we can draw the tangent by using the second equation. But in first equation and second equation, the some coefficients are there, the constants are there, and we're supposed to calculate this constant by putting the boundary condition. The first boundary condition, that means u is equal to 0. If value of u is 0, the p will be equal to p0 and p dash will be equal to p0 dash. So first I put the first boundary condition. Now I am putting the boundary condition u is equal to 0. At u is equal to 0, the value of p of u is p0 and p dash of u is p0 dash. These are the boundary condition at u is equal to 0. If u is 0, pu is p0 and pu dash is p0 dash. These are the boundary condition. I have to put this boundary condition in equation 1 and equation 2. First I will put the boundary condition in equation 1. Pu is p0 plus c0 plus c1u, value of u is 0. So c1 into 0, 0 plus c2 into 0 square, 0 plus c3 into 0 cube, 0. So p0 is equal to c0. Suppose it is equation number 3. In equation 3, I have calculated the first coefficient c0. The value of first coefficient c0 is p0. And same boundary condition I have to put in second equation. If I put in second equation, pu dash, I can write p0 dash plus c1 plus 2 into c2 into u, value of u is 0. तो ये term हो जाएगा 0 plus 3 into c3 into u square, the value of u is 0. Then again 0. That means p0 dash is equal to c1. It is equation number 4. So I have calculated two coefficients c0 and c1. I am writing here. First coefficient is c0, which is its value is p0, and c1 second coefficient whose value is p0 dash. Okay, and c2 and c3 I am supposed to calculate. Now I have to put second boundary condition. First boundary condition was u is equal to 0. Second boundary condition is value of u is equal to 1. Then pu will be p1 and pu dash will be p1 dash. So I am writing here second boundary condition at u is equal to 1, then pu will be equal to p1 and pu dash will be equal to p1 dash. Same boundary condition I have to put in equation 1 and 2. The equation 1 is c0 c1, value of u is 1, then value of u is 1, here 1. So p1 will be equal to c0 c1 into 1, c2 into 1 square plus c3 into 1 cube. So I can write here p1 equal to, so p1 is equal to c0 plus, in first equation if I put u is equal to 1, c0 plus c1 plus c2 plus c3. So c0 plus c1 plus c2 plus c3. Okay, so c0 and c1 का value we already have. c0 is p0, c1 is p0 dash. So we can write p1 is equal to, instead of c0 I can write p0, instead of c1 I can write p0 dash plus c2 plus c3. It is equation number 5. And same boundary condition I have to put in equation number 2. Second equation we have to put same boundary condition. The value of u is equal to 1. Then here you will get p1 dash. Here we get p1 dash will be equal to C1 plus 2C2 plus 3C3. So in that equation, equation number 2, we have to put U is equal to 1. C1 plus 2C2 plus 3C3. The value of C1 is P0 dash. So instead of C1, I can write P0 dash. So instead of C1, I can write P0 dash plus 2C2 plus 3C3. And this is the equation number 6. And from equation 5 and 6, we're supposed to calculate C2 and C3. These two coefficients I have to calculate by using equation 5 and 6. So first I will calculate C3. तो C3 calculate करने के लिए I have to cut C2. तो I have to multiply the equation 5 with the 2. Coefficient 2 से multiply किया तो we will get 2C2 मिलेगा and then minus 6 से. तो here I am writing equation 6 minus 2 times equation 5. If I multiply coefficient 2 with the equation 5 and subtract from the equation 6, then C2 will get cancelled, will get coefficient C3. These are the two equation 5 and equation 6. Two equation, only two unknowns are there, C2 and C3 are the unknown. You have to calculate C2 and C3 by using these two equation. The first equation 6 I am writing from here, P1 dash minus 2 times P1, P1 dash minus 2 times P1 equal to this equation 6 P0 dash plus 2 C2 plus 3 C3. ये इक्वेशन नंबर 6 माइनस करना है इक्वेशन 5 को 2 से मल्टीप्लाई करके 2 P0 माइनस 2 P0 dash minus 2 C2 minus 2 C3. They have to multiply the equation 5 with the two coefficient 2 and minus and subtract from the equation 6. So this 2C2 and this 2C2 will get cancelled. Only C3 is remaining. So here I am writing P1 dash minus 2P1 is equal to here P0 dash. Here P0 dash is here. So P0 dash minus 2P0 dash. I'm getting minus P0 dash. And C3 is here and C3 is here. So 3C3 minus 2C3. So we'll get plus 1C3 only. Then plus minus 2P0. So C3 will be here. Remaining are to shift there. C3 P1 dash minus 2P1 plus P0 dash plus 2P0. So this is the value of C3. P1 dash minus 2P1 plus P0 dash plus 2P0 is the value of C3 coefficient का value. Suppose equation number 7. I got the C3 coefficient का value. Now I have to calculate C2 का value calculate करना है. तो सेम इक्वेशन वैसे लिखेंगे इक्वेशन 6 minus 3 times equation 5. If I multiply the equation 5 with the coefficient 3 and subtract from 6, then C3 will get cancelled and we'll get the value of C2. So same equation I have to write P1 dash minus 3P1 instead of 2 I have to write coefficient 3, then P0 dash plus 2C2 plus 3C3 minus 3P0 minus 3P0 dash minus 3C2 minus 3C3. So this C3 will get cancelled. C3 and C3 will get cancelled. So I can write the P1 dash minus 3P1 equal to P0 dash and P0 dash is here. So 3 and 1. So minus 2 I get minus 2 P0 dash. C2 is here, C2 is here. 2C2 minus 2C2 minus 3C2, we get minus C2, and P0 is here, so minus 3 P0. C2 will be here. I have to shift there, C2. So C2 will be equal to minus 2 P0 dash minus 3 P0, and you have to shift there, uh, minus P1 dash plus 3 P1. Okay. So C2 will be equal to P0 dash, only one P0 dash is there. So minus 2 P0 dash, P0 minus 3 P0 minus P1 dash plus 3 P1. Equation number 8. It is the coefficient C2, C3 we have calculated. Minus. Now to put this all four coefficients in equation 1 and 2. So from in equation 1 we have to put all four coefficients C0, C1, C2 and C3. All four coefficients are to put in equation number 1. So I am writing equation 1 again. Put all by putting all four coefficients. So P of U will be equal to in equation 1. So this is the equation 1. P of U first is C0. C0 की वैल्यू है C0 is P0. First is C0. First I will write the equation C0 plus C1U plus C2U square plus C3U cube. ये equation था PU का. I have to put all four coefficient in that equation. We know the coefficient C0 is P0, C1 is P0 dash, C1 is P0 dash, C0 is P0, and C3 is P1 dash minus 2 P1 plus P0 dash plus 2 P0. P1 dash minus 2 P1 plus P0 dash plus 2 P0. And C2 is minus 2 P0 dash minus 3 P0 minus P1 dash plus 3 P1. So this all four coefficient are to put in this equation. So I'm writing this equation P of U will be equal to, instead of C0 it is P0 plus, instead of C1 it is P0 dash U plus, instead of C2 you have to write this, so U square into C2 is there, minus 2 P0 dash minus 3 P0 minus P1 dash plus 3 P1. This C2 is coefficient multiplied by U square plus U cube into coefficient C3. C3 is P1 dash minus 2 P1 plus P0 dash plus 2 P0. If I multiply this coefficient with parameter U, we'll get PU P0 plus P0 dash U minus 2 P0 dash U square multiply with the U minus 3 P0 U square. U multiply this minus p1 dash u square plus 3p1 u square. Just multiply this parameter u square with this coefficient plus p1 square u cube minus 2 p1 u cube plus p0 dash u cube plus 2 p0 u cube. So I'm multiplying this parameter u cube with the coefficient c3. So first is u cube multiplied by p1 dash 2 p1 u cube p0 dash u cube 2p. Now you have to separate this. First all p0 term and then all p0 dash term and then p1 term and then p1 dash term. तो ऐसे separate करेंगे हम. तो first pu all p0 term. तो p0 is here, p0 is here, and then next p0 is here. So minus 3 p0 u square. Then again I have to check one more p0 is here plus 2 p0 u cube. These are the 1, 2, 3 p0 ka term. Then I have to write all p0 dash term. So p0 dash is here, p0 dash u. This is a p0 dash. Then one more p0 dash term is there minus 2 p0 dash u square, and here p0 dash is there. So plus p0 dash u cube. Then you have to write all p1 ka term. So p1 term is here, p1 term. So plus 3 p1 u square, and then one more p1 term is here minus 2 p1 u cube. Okay. Then you have to write p1 dash ka term minus p1 dash u square. P1 dash is here, and one more p1 dash is here plus p1 dash u cube. So p of u will be equal to, so I am taking p0 is common, p0 is common, 1 minus 3u square plus 2u cube. p0 is common, 1 minus 3u square plus 2u cube. Now I am taking p0 dash is common, p0 dash is common, here u minus 2u square plus u cube. p0 dash I am taking common, then I am taking p1 is a common, p1 is common, 3u square 3u square minus 2u cube. If I am taking p1 is common, then I am taking p1 dash is common plus p1 dash is common. Suppose p1 dash is common, here u cube minus u square plus u cube. Okay, so this is the final equation, equation number 9. By using this equation, we can calculate the points on the curve. So this is the final equation. Pu is P0, 1 minus 3u square plus 2u cube plus P0 dash u minus 2u square plus u cube plus P1 3u square minus 2u cube, and P1 dash minus u square and plus u cube. This is the final equation to calculate the points on the curve just by varying the parameter u. Here only u is unknown. You have to vary this parameter u from 0 to 1, and you have to calculate the points on the curve. The same, the points, if draw it on this curve, the point is here, P point. तो इसके दो components होंगे, x component and y component. So you can calculate the x component, y component by using this point. So suppose I want to write in terms of x and y के term में लिखना है. तो x of u will be equal to x0 1 minus 3u square plus 2u cube plus x0 dash u minus 2u square plus u cube plus x1 3u square minus 2u cube plus x1 dash minus u square plus u cube. The same equation I am writing in term of x. Similarly, you can write in term of y. Y will be calculated by using y0 1 minus 3u square plus 2u cube plus y0 dash u minus 2u square plus u cube plus y1 3u square minus 2u cube plus y1 dash minus u square plus u cube. These are the equation. In that equation, parameter u is varying from 0 to 1. Just change the parameter u 0 to 1. These all are the known. x0, y0 are the x and y component of the start point of the curve. x0 dash and y0 dash are the tangent vector on the curve at a start point. x1, y1 are the x component and y component on the curve at end point, and x1 dash and y1 dash are the tangent vector on curve at end point. So these four boundary conditions already known, and just have to change the parameter u from 0 to 1, and then have to calculate x component and y component, and just draw the curve. We can see here on PPT. This synthetic curve, the Hermite curve or cubic spline curve. This is a curve with the four different boundary condition, and by using the boundary condition, here I am writing the equation in term of p and p dash. If you differentiate this equation, we will get p dash ka equation. This equation is used to draw the tangent vector on the curve. By using this equation, we can draw the tangent on curve at any point. By using this equation, we can plot the curve. We will get the points on the curve. So same equation, this first equation I'm writing in term of x and y and x and y. The second equation, same equation I'm writing in term of x dash and y dash. So these two equation are the tangent vector ka equation. This equation is tangent vector ka equation, and this equation is to draw the curve. Okay. In next lecture we'll see how to draw the curve on graph paper. So we'll solve one numerical question on the Hermite curve in next lecture. Okay.